Good evening, friends. Some more examples in divergence theorem. We have seen the formula and the theorem yesterday in the last video. Now example 1. Evaluate the integral of f factor ds with f factor such that z minus x squared minus 2xy minus 2 and s the boundary of region enclosed in the top by plane z for 4 and below the paraboloid z equal to x square plus y square. Solution is the formula required to find out Gauss divergence theorem is integral surface integral f factor d s factor equal to integral volume integral del into f factor into dv. And we got to find out first del into f factor. Del into f factor is del is nothing but the partial derivative of the given function. Therefore, the partial derivative of the function we got to find out, that is dou by dou x of z minus x squared, dou by dou x of 2xy, dou by dou z of z. Then we have, when you are differentiating with respect to x, we get minus 2x, this becomes 0. And when you are differentiating with respect to y, we get plus 2x. And with respect to 2, it is a constant term, therefore 0. Therefore, del dot f factor equal to 0. Therefore, the answer is integral s surface integral f factor dot ds factor equal to integral volume integral del dot f factor dv equal to integral 0 dv. We got to substitute this and 0 into dv, that becomes 0 only. The answer is 0. The next problem, second one, evaluate integral surface integral f factor ds where f factor equal to 4x zi minus y squared j plus y zk vector. And S is surrounded by the region x is equal to, the limits are x is equal to 0 to 1, y equal to 0 to 1 and z equal to 0 to 1. Find the divergence theorem. Then integral s f factor ds equal to integral volume integral del dot f factor into dv. Then you have to find out first del dot f factor. Del dot f factor is nothing but integral dou fx f by x partial derivative with y and z. These v dv represents the changes in x, y, z due to the force. Therefore, you have, when you are differentiating 4xz with respect to x, we have 4z, x become 1s. And when you are differentiating y square, we get minus 2y. And differentiating z, we get plus y into dz into dy dx. Then taking the innermost integral, we have integral 0 to 1 y z y x 4z minus 1 to dz into dy into dx. Then you have differentiating with respect to dz first and then get 4z squared by 2, then these 2 and 4 getting cancelled, 2z squared minus y into z and this vanishes and substituting the upper limit only, then dy dx. Upper limit we get 2y 2 minus y. Then into dy dx 0 to 1 0 to 1 for the x, y and x. Then again integrating with respect to y, we get 2y minus y squared divided by 2 and substituting the upper limit we get 2 minus, that is substituting 1, 2 minus 1 by 2, that is 4 minus 1 by 2, that is 3 by 2 into x. Then substituting in the formula we get 3 by 2 into x, that is 0 to 1, then substituting x is equal to 1, you get 3 by 2. The value is 3 by 2. Thank you.